Today I've been thinking about all the design patterns that we use in our code on a daily basis, and then I realized that I definitely have some of them among my favorites, and I also have some of them that I don't really like that much. And I thought, actually why not try to rank them in one of my videos, with the help of Node.js, which means we're gonna take a look at the code of those design patterns and discuss the possible use cases where you could use one of them. This video is based on the article of Fernando Doglio, which is exactly about the design patterns of Node.js. So if you're curious, go check it out. It's an amazing article. And with that said, we're gonna start with the first design pattern called Observer that I'm gonna try to rank. So let's take a look at the code. The Observer pattern is basically consisting of two parties, an observable and the observer. An observable in this case is the server that all of us have used many times. So whenever you're creating a Node.js server, you instantiate a server and then it is an observable. And observers are things like server on.error or server.listen. So we're listening to different kind of events and then we're reacting on them. So what's the difference between an observer design pattern and a pub/sub pattern? Well, in the observer design pattern, the observable knows about all of its observers. So in this case, the server knows that we have event listeners here. In the pub/sub design pattern, the publisher has no idea about the subscribers. So it emits an event and the subscribers get the event, but the publisher is not aware of the subscribers. So this is a difference. So the use cases would be something like this, where you can have an observable class, doesn't have to be an observable, can be a service, where you have a list of observers registered. And of course, you can create like on input events, and then you can trigger those inputs. So this is one use case, but the most common one is called event emitters. You definitely know about them. And I actually made a dedicated video not a long time ago on those. So event emitters are exactly the observer pattern. So we are registering an observer. So on user deleted, for example, whenever a user has been deleted from our platform, and as soon as the user is deleted, we're simply emitting this event with the same name. And then the observer can actually react on this event. So what are the common use cases? For example, this one, when a user has deleted their account from our platform, from our application, we can actually take the email from the username and first of all, maybe delete this user from all the caches that we have, delete this user account from our database, and also send them an email confirming that their account has been deleted. You can do all of that asynchronously, meaning you can put kind of event listeners or observers in different services within your application and then do all of those operations asynchronously, meaning in parallel, if you think about it. Well, I think this one is very useful, so I would actually put it to me gusta because I like it a lot. And I definitely would have used it to speed up my application. Then the next one I want to talk about is the command. So what is the command design pattern? The core idea here is that the command design pattern tries to encapsulate kind of complicated behavior in a simple API. So the command class that we're going to extend when we create our actual commands, for example, log command, welcome command, we're extending it from the base command, and we try to have exactly the same, if not similar API for our classes. For example, as you can see, we always have this run method, and we can put the logic within this run method. Now, what does it give us? Well, if you look at the use case here, we're going to have an array of commands, and then we're going to put the instantiations of the object or the class one by one after another, and then call the run method on all of them. So first of all, it's very simple to read because we only are running or relying on this run method. And the second thing that you probably can also see is that we have a chain here, or rather a sequence. So if we say node command.js, this sequence is going to be fired one after another. So a potential use case would actually be logging as we're doing here. So let's say your application is being interacted or the users are using your application and you want to set up some logging. Maybe you want an error logging if there's an error within your application. You want security logging if has been some security mechanisms triggered. and you can also just monitor the activity within your application. So you can literally put those 3 different types of logging behaviors within one array and then run or activate them by invoking the run method. This is the command design pattern. Now, where would I actually rank it? I would say I'll use it. I think it's pretty useful when you know that your business logic consists of a specific sequence, and then you can kind of use it as a command. Well, the next one is going to be the builder command. And let's take a look at this one, because I think this is the one that I use the most within my application or within my day-to-day job. So the builder command is meant to simplify the instantiation of the class. So imagine we have a house class and we are trying to supply like bedroom, bathroom values and kitchen and garages. But imagine a use case where we have literally 30 parameters or arguments that we can supply here. Now, the instantiation of this class, let's say new house, not like this, new house, and then you have to supply all of these arguments, like 30 arguments. And especially if one of those arguments has a specific logic, let's say it depends on whether the number of bathrooms is higher or lower, you're going to set a different value. So there's some kind of an if statement inside. This is going to be a huge class instantiation. So that's really not nice, and it's not that flexible, as you can see. So what we can do instead is we can rely on the builder design pattern. So here we're going to have a house builder, which accepts a constructor. And then a very specific to the builder design pattern is that we have setters. So we can set bathrooms, set bedrooms, set kitchens, and set garages. And most importantly, we have this build method, which actually returns this house class by supplying this inside it. And then when I'm talking about flexibility, it's exactly that. So in the first case, we can create house 1 and then supply all the values here. But also, we can also create house 2. And as you can see, this one is lacking garages. So this one doesn't have any garages. And our instantiation doesn't break. We can also remove the kitchens if our house doesn't have any kitchens. And also change the number of bathrooms to 10 or bedrooms to 10. So as you can see, this is very flexible. And just by using the builder method, we can create different types of classes in a very flexible way. So when would you use this? This one is actually for simplifying your code. So if you're really caring about your code structure and cleanliness, definitely you can rely on this one if your code is, or if your classes are sophisticated and you need more flexibility. So I would say builder definitely gives a good dopamine hit. So I would put it here. Now the next one I want to discuss is the prototype pattern. And as you know, prototypes are always has been the core of JavaScript. And here the traditional prototype pattern, of course, it's an object and it has a method. For example, they say hello, and it also has properties. All right. And you're always able to clone it. So we're going to also have a clone method. What the clone method does is it creates a new object. So object.create, which means it has its own scope. But we're also supplying this, meaning we're supplying all the values that we have here by default. And then if you do prototype.clone and create a new variable from here, you can access pretty much the same things, or rather the copies of the same thing. And of course, you can modify them. So if we try to run this prototype.js, we're going to get Hola world because this has been overwritten. Actually, one of the use cases is caching. For example, let's say you're building an application where in the memory you can have one cache, and then this cache gets invalidated. You want a copy of this cache and then build a new cache on it. So we can create a cache, all right, cache prototype. We can set all of our data, and then we can create a new cache based on the old cache. So as you can see, our prototypes or prototype instantiations are depending on each other on the prototype chain, which means we're also going to save a lot of, this code is going to be much performant because our prototype chain is just linked by one and after another. So if we're trying to access the new cache and one of the values that have been declared in the previous cache it's going to point in the same place in the memory. All right. So these are the 4 design patterns that I wanted to discuss in this video. Of course, didn't have enough time to go over all of them. So we're also going to look at all of these in the next video. So definitely subscribe. And before I say goodbye, I need to rank this prototype design pattern, and I'm going to put it as I'll use it. I think there are pretty good use cases for it. So if you like this video, definitely smash like and subscribe, and I'm going to see you in the next one. Goodbye.